slightly different. You know how to take average. Yeah? You know how to take average of two numbers. But here, we have many numbers. We need to take average, but there is a probability to be considered in your average. Yeah. So this kind of average we call the weighted average. There is a weight. Yeah. Weighted average. Yeah. Here. So let's do the weighted average. Okay. All right. How do we do the weighted average? We put a weight. So each subcase, there is a weight. We associate appropriate weight number. Yeah. Two-step calculation. Subcase averages and overall average. Yeah, there is a subcase. Yeah, the subcase average, then overall average. Yeah. So we do it in that way. Yeah. All right. First, let us consider all these n cases together as the subcase. Yeah. One subcase covering all these n cases. Yeah. Each one probability 1 over n, right? Yeah. That's our assumption. Yeah. So now, how many comparisons for this subcase? Look at the subcase. Okay? Yeah. Weighted, this is also weighted average, but the weight 1/n, 1 over n. Yeah. Or another way you view it, you just add up all the comparison numbers divided by n. Yeah. That's our usual understanding of average. Adding up all the numbers divided by number of items. Yeah. So that is our subcase average. Yeah, because this number is covering the subcase. Match case, match subcase. Yeah, there is a match. The first subcase, there is a match. Second subcase, no match subcase. Yeah. But, sorry, yeah, I need to go forward. Yeah. No match subcase, only one case, so average is itself. Yeah, only one number. Yeah. Yeah, all right. But for the first subcase, probability is P. The second subcase, the probability is 1 minus P. 1 minus P. Yeah. Now that's the weight. First subcase, the weight is P. Second subcase, the weight is 1 minus P. Weighted average. Okay? So let us write the formula. Combine two subcase averages based on their probabilities as the weights. Yeah. The number of comparisons for the first subcase, multiply its probability as the weight. The number of comparisons for the second subcase, multiply its probability as its weight. So this number is the weighted average. So at the end, we write this formula. Okay? Yeah, that's it. So, but you need to understand the meaning. When you apply it, you need to understand what's the meaning. Yeah, the P and yeah, the whole story. Yeah. And when you, yeah, because usually when I give you questions, I describe some environment, okay? Yeah. Give you some conditions, yeah, yeah. So then you need to, based on your understanding, do some appropriate modification. Then you apply the formula, yeah, in the right way. Yeah. The reason I say this, because many times, based on my experience, many students, they just find the formula and plug in. Yeah. They may not do necessary modification, yeah, because sometimes I may put some special condition to change something. Yeah. I put some condition to change something. Okay? Yeah. So then you should be very careful when you apply the formula. Yeah. All right. Any question at this point? Yeah. All right. Yeah. So we complete. Yeah. All right. Next. Yeah. After we have the formula, now I want to introduce another important concept called dominant term. Dominant term. So here we do some preparation of Module 2. In Module 2, we will learn asymptotic notations. So in order to understand asymptotic notations well, we need to learn this concept, dominant term. Yeah. Here you can see we have many terms. Some term dominates other terms. That's important. Yeah. So here you can see this +1 is not important, yeah, because it's small. Okay? Yeah. If we look at the number, especially when the number is big, this +1 is very little. We can ignore it. If we look at a dominant term, we can ignore it. Yeah. So you can see, to look at a dominant term, those minor little terms can be ignored. So n is the variable. If we combine all the coefficients of n, yeah, here let me write something a little. Yeah. From the first part, 1/2 n plus 1 ignored, so you have 1/2 p times n. The second one, all right, 1 minus p, all right, be careful. Do not ignore 1 here and minus p, do not ignore that, because n multiply this number. You cannot ignore. Here, n plus, yeah, plus this number, yeah, we can ignore. Multiply, because n is big. Think about it, n is big. If we ignore some number inside the parentheses, after multiplication, it could be very big, right? So don't ignore. Yeah, sometimes one cannot be ignored. Sometimes this one can be ignored. Depends on the position. All right? Yeah. So the second one, the coefficient is 1 minus p times n. Yeah. Now you add 1/2 p plus 1 minus p, you get this 1 minus 1/2 p. That's the coefficient of n. N is the variable. Yeah. P is constant. P is constant. Yeah. Yeah. Given constant. Yeah. 1 minus 1/2 p, that's the coefficient of n. Yeah. So this whole thing together, we call the dominant term of this expression. Average case efficiency expression. Dominant term. The remaining minor terms. Remaining minor terms. Now sometimes we can ignore the minor terms. Yeah. All right.